Uh,
Good.
okay, good morning, everyone. Today I will present on the ocean plan design, and these are the contents that I will cover in my presentation. First of all, to start off, this is a brief picture of the deep water field layout for extraction, and you can see there are many different units, and there's a subsea drilling system and satellite subsea trees. You might not be familiar with these units, so I will explain them. So deep water is when the plant is deep into the sea, where it's generally, according to documents, the depth is of the seabed is about 5,000 feet, more than 5,000 feet. So what are these units like satellite subsea trees? So basically, you can see this is the main drilling system over here, but there are also small units which are small drilling units like these at the uh, seabed level, and they are mobile and really small. So they are used to extract hydrocarbons from the outer fringes of the field, and they can extract different kinds of hydrocarbons. So these trees, these subsea trees are basically connected to the satellite well, and that's why they're called satellite subsea trees. And they're basically used to control the production. As you can see, like here, we produce the hydrocarbons, and these trees used to control the production. And there's also another unit we see, subsea manifold. These are basically arrangements of pipes and wells. They're designed to combine, distribute, control, and often monitor the fluid flow. We also have a subsea processing unit. This is for the liquid and gas separation generally. And over here, you can see a smart well control system. These control systems basically prevent like uncontrolled, uncatastrophic release of high pressure fluids from the subsurface formation. And let's move on to the next slide. And in this slide, we can see the supply chain of offshore oil and gas plants. And you can see the supply chain of oil, gas, LNG, and FLNG. So some of you might not be familiar with FLNG, which is basically stands for floating LNG production, not near shore or inland. So I have a video prepared for you guys, so you can understand FLNG better. Yes. I'm not sure if you can hear the noise, but so FLNGs are like really, really massive vessels, and they have all the units which I showed you previously, and most of the units are inside the vessel, and it's like really, really huge ship, and it's like one of the recent developments in science in the ocean engineering. So these are different from the inland. So we can see all of those require the drilling rigs, obviously, and subsea systems for the processing and controlling the fluid flow. So the difference comes in the production and the storage. So oil and gas, they are fixed platforms. Why? And also for LNG, but for the storage is through pipeline. And for FLNG, there's like carriers which first store and then bring to the shore, which are called LNG carriers, as you can see in the transport part. Um, the supply to the consumers is done using these methods. Oil is stored in a tank farm where it is refined, and gas is simply sent through the pipeline to the consumers in our houses, as we see in our daily lives. And LNG terminal, there is FRU, FSRU, which stands for floating storage and regasification. This is another vessel. It's like really huge as well, and it's at sea. It comes near the shore, and then it directly pumps the gas it first it um, if it's in the LNG is in liquid form, so it converts into gas and then pumps into the pipes which lead into our homes. Uh, yes, to the consumers. And so let's move on. Let's move it back. So as we saw previously, all the plants offshore and at shore have drilling units. So these are three types of drilling units. You can see submersible, which by the name you can understand it's somewhat submerged into the sea. And there's jackup and there's drill ship. So you can understand by them, but you don't understand what's going underneath the sea. So I have another slide, as you can see over here. So the first one is the jackup, and second one is the drill ship, which is used. And in the jackup,
just a moment. The left one
yes.
is semi-submersible rather than jackup.
Submersible. Sorry, that's my mistake. And it's like semi-submerged inside the sea. And this is the drill which is used. And these, as you can see, these wires are basically to provide more stability. So semi-submersible platform as compared to the drill ship has good ship stability and is also better sea keeping than the drill ships. And for jackups, I have this video in which I'll show you. So these are the jackup drilling units. You can see like there are small boats which first bring them to the reservoir location. So these are for moving the whole platform. Yes, like this. And then they position the these three small boats. These position the jackup, and then these pillars they move downwards and embed into the seabed, and basically they lift the whole platform up. It's like this. So this one even has more better stability than the submersible. So we looked at different kinds of drilling units. So now we have another theme layout, which is a little different from the previous one. The previous one was deep water, but this is shallow water. Shallow water is basically for water near the shoreline where it is not too deep, as compared to the previously where we had deep water, which was like a 5,000 feet deep. And now the seabed is not that deep, and it is usually near the shore. So this layout has the same units, but it's just near the shore and it's not that deep.
Can I add something?
Yes.
You finish this slide, then I'll ask.
No, you can go ahead, ask your question first.
So in the previous slide, the submersible, how is it like submersed? I mean, how is it like semi-submersed? It's not floating direct, like totally, or it's not sinking totally. It's like they're somewhere in the middle. Is there like air inside or something? And also are they like anchored to the seabed or what?
Yes, as you can see, like, yes, Professor.
Go ahead, and then I will add.
You can see like they're anchored into the seabed. Not anchored, like these are like fixed into the seabed. These wires are basically to provide more stability, and these wires can be used to submerge it into the seabed and basically not move horizontally or this way. So this is basically for more stability. as you know, there's the drilling pipe is really long, and it should be stable so that proper extraction can be done.
Why is it not sinking? I mean,
I think it's because of the hull structure over here, or they could make another. It could be another technology, but yeah.
It is the same story as the ship at the right-hand
Yes.
side. Ship is
I see.
made of steel, but they are floating because of what? They provide a bubble, air inside, captured inside the structure.
Yes.
So semi-submersible get the, we call this is a buoyancy. Buoyancy is provided by the hull inside the water. So they are submerged hull. Right? So it's a floating type, but different type of floating. Same as a
Thank
ship.
you.
Right. And then the wires, the thin wires, we call this is a mooring line. And they do only for not moving the floating ones. Okay?
I see. For stabilizing.
Because there is a current, water is moving and wind is blowing and wave is coming. So the function of the wire that we call the mooring line is for position keeping. But at the right-hand side, there is no mooring line, right? At this type of ship, they have a very expensive device called dynamic positioning. They use several small propellers attached to the ship. They do combinations similar to drone, right? Drone is position keeping by controlling the several small propellers. Right? So we call this a dynamic positioning rather than static positioning by mooring. Okay, we will see more in naval architecture term in the later stage of semester.
Thank you.
Right? Right.
Thank you, Professor. So we looked at this shallow water layout, and this is how the processing unit of it looks like near the shore. And this is one of the examples of offshore installations. And it is one of the most remarkable achievement in science and technology. It's called Troll A in Norway. The Troll A platform is a offshore natural gas platform in the Troll gas field of west coast of Norway, and it is the tallest and heaviest structure that has ever been moved to another position. It's remarkable in its own kind. It's really unique, and it was positioned relative to the surface of the earth, and it is like one of the most complex engineering projects. And so previously in the transport section for LNG in the supply chains, we looked at LNG. Sorry, we looked at LNG, FPSO, and LNG carriers. So LNG FPSO stands for floating, production, storage, and offloading. And then there are LNG carriers. These carrier basically load in all the LNG and then transport it near the shoreline. And there is another type of special carrier, which you will see in the next slide. Yes, this is called, it is special in its own kind because it's called FSRU, which stands for Floating Storage Regasification Unit. So it's different from the previous one, as there is an R which stands for regasification. Regasification, as you all know, is a physical process by which the liquefied natural gas is heated and returned to its gaseous state. So why do we do this? LNG is a really environment friendly fuel, but the fact still remains that it is really dangerous. So the LNG is transported by the LNG carriers in the form of liquid, because which is at a semi-cooled slushy state at a temperature of minus 60 degrees, and then um, uh, it is after it is delivered by the LNG carriers in the liquefied form, it is offloaded. It is received by this unit, which is called FSRU. So what this does, it regasifies into the natural gas before pumping into the main pipelines and then received by the consumer. So, so this process is for regasification of natural gas. So this whole unit is built for that, and you can see this. This is the whole structure where it happens. So now I will cover some other offshore installation and concepts, which the first one you have already looked at, which is called mobile harbor. So this is the world's first ship-to-ship automatic docking system concept developed, and it is basically to provide a reliable solution for docking between two ships exchanging containers in the ocean. So in this, you can see that first the ship docks into this mobile harbor, and then there is a crane which is used to move the cargo from one ship to another. And this one we also have looked at already, which is called the MIT's offshore floating nuclear power plant. And as Professor explained previously, this is more safe as there is water around and no land is required. So this is a concept and still in development. And here we look at the Kai's own designed offshore floating nuclear power plant, which is with also enhanced safety safety features. And this was developed by Kai's. I have the paper in which this was published. Yes, if you want to look at the details, you can look up to this paper, and this and so they also to basically to test out their sorry. So to test out their design, they also made a model of this one and implemented into the sea, and it worked really well. And they did a lot of tests on it as well. And now we will look at another offshore these floating structures, which are in the form of wind turbines. As you know, we can see land fixed, ocean bottom fixed, and floating. And we all are very familiar with the first one and the second one probably, but the new one which is currently into development is the floating wind turbines. And so the merit of the land fixed is that it's relatively economic, as you all know, as compared to the other ones, and it is easy for maintenance and operation. The second one in the ocean bottom fixed. So this at the ocean, we all know the winds are really fast. So this is better for production, but the installation is a little expensive than the left one, and it has reduced vibration. As you can see, this structure goes inside the seabed. It's attached to the seabed, and it doesn't move. But on the right hand, we have floating wind turbines, which is one of its own unique kind, and it is for the deep waters or into the water. And this is so these are basically inland, and they can really move. The floating structures can be moved by waves, so they're not as stable as the previous one, the land fixed and the ocean fixed. So this is one of the shortcomings of the floating wind turbines, and this is currently into development and And the floating one is more expensive as well, to provide more stability. And so if we look at the prices, I think the most expensive one would be the floating one. And I think there's not much else to cover in these, but yes. So this is the end of my presentation. Do you guys have any question?
Yes, I have a question about floating wind turbines.
Yes.
Like how do they keep the balance? Like do they have wires like you told before?
Yes, just like we saw in the submersible, the similar mechanism is used in the floating. So as you, I don't know if you can see, but this picture, but they're also like similarly like the submersible drill units we saw. There are wires and which are attached to the seabed for it's to provide the positioning of basically to provide the positioning of the wind turbine, because in deep waters the currents and the waves could be really high, so it is really important. But um, the stability, I think, as you mentioned, is one of the biggest problems to be overcome in this technology of the offshore wind turbines. So yeah.
Thank you.
And I had one question. The power generated from the floating one wind turbine, how is that
Yes.
stored? Is it like, is there like a battery or something that needs to be refilled, or
Yes.
is there like cable?
No, it's actually there is a battery for that one. So yes, it's a really big one. And another problem with floating one is that uh, the the positioning of the wind turbines. So it has to be done from another ship which brings it into the offshore. So that is also a problem. So and it changes it extracts the electricity produced. So yeah, that is another problem with the offshore wind turbines.
So basically, a ship goes and brings like batteries and replaces the batteries and brings back like fully
No, it
charged
doesn't
batteries. Or
replace. No, it doesn't replaces the battery. It just takes in the
I see.
electrical power. Yeah.
Let me explain this. Usually they have a cable, electrical cable. You see, for land-based power plant, they also need long distance cables from the power plant to the homes. Right? Similarly, these they may need a little bit more extension of cables. Usually they have a cable. But another idea, I'm not sure whether this is already realized, but they have an idea that they produce hydrogen using that energy, and then ship is coming to offload, transport that hydrogen liquid. There is the idea, and I heard that there is a project ongoing. I don't know whether this is finished or still going.
Interesting. Thank you.
And about stability and buoyancy of a high wind case in floating, the submerged part is a cylinder, and cylinder inside is a cavity, so air is inside. So the forces, the weight is balanced by the buoyancy coming from the air and submerged. And about stability, two things. One is usually they have a very heavy weight at the bottom of the whole cylinder. Something like I don't know what is the English name of otugi in Korea. There is a toy. They never collapse, right? Because of the very heavy weight at the bottom. Similarly, they do things, and also they also have mooring lines together. All right.
So does anyone else has more question?
Okay, thank you. And then say we may have a short break, 3 minutes, and then we move on to discussion session led by Mr. Go, Chang-un Go. 3 minute break, please.
Thank you, everyone.